Hey everyone. In this video we're going to be talking about how to, first of all, calculate the slope without drawing, and also how does it relate to the equation of the line. So remember from our first method that we only really need 2 points on the plane to define a line. From the plotting points method we would draw 3 just to make sure our work is okay, but really we only need 2 to define a line. If we only need those 2 points to define the entirety of the line, we should be able to use those 2 points to figure out the slope as well. So say we want to calculate the slope of the line between the points 2, 3, and 7, 6. Now, you could go through all of the motions using the method of plotting points, and then you would have to draw your axes, and then you plot the points, then you draw the line. Once you draw the line, then you count how far to the right you move, and then you count how far up or down you move as well. And then finally you would get the slope is 3 over 5. But we can get this number 3 over 5 without doing any of that other stuff, right? Depending on what resources you have, graphing might take kind of a long time, might be kind of a cumbersome task. So let's talk about the formula and where it comes from. Suppose that you have x1, y1, and x2, y2. Quick aside here, the subscripts 1 and 2 sometimes are read as x sub 1, y sub 1, and x sub 2, y sub 2. It's really just to signify that x and y with subscript 1 belong to the first point, and the x and y with subscript 2 belong to the second point. So you have 2 points, which means you have a line that they're both on. Now, that x1 being the x-coordinate of the first point means that you travel x1 units to the right or to the left, depending on whether x is positive or negative, and y1 units up or down. And for the second point, you're traveling x2 units to the right or left, and y2 units up or down, depending again on whether or not they're positive or negative. This is just coming from how we graph the points. Remember that the change is the length of this green line here. That is, it's how far I move from x1 to x2, and then from y1 to y2. So it's the lengths of those green lines that's going to allow us to calculate the slope, which is a vertical change divided by the horizontal change, or rise over run. We often denote the length of these green segments with a Greek capital delta, which is a triangle. So we have delta x being the length of the horizontal green line, and we have delta y being the length of the vertical green line. And oftentimes in mathematics, when we have a delta next to a variable, it's read as the change in. So delta x means the change in x, and delta y means the change in y. Now, keeping in mind that the slope is given by the vertical change divided by the horizontal change, the equation of the slope would be delta y over delta x. How do we figure out what delta y and delta x are? Well, remember that it's the change. So to get the length of the line segment of delta x, I would have to look at the length of the line segment of x2, and I would have to subtract out the length of x1. So that delta x would really just be x2 minus x1. And same deal for the y coordinates. the length of the green vertical line segment would be given by the length of this orange one, y2, and then we subtract the length of this shorter line segment, y1, which would be y2 minus y1. Now keep in mind that this is just a picture to build your intuition. The picture would look obviously a little bit different if you are looking at a line with negative slope, right? This one has positive slope. But the idea is fundamentally the same. It also doesn't really so much matter which point you call x2, y2, and which point you call x1, y1, so long as you're consistent in the formula. So let's go back to our previous example. We want to calculate the slope of the line between the points 2, 3, and 7, 6. Out of convenience, I'll just choose this first point to be x sub 1 comma y sub 1. But again, it doesn't really matter which is 1 or which is 2. So long as the correct numbers are paired together. And the slope of the line is 3 over 5, just as we discovered earlier. So for our purposes, if you're handed 2 points of a line, it's not really too hard to graph them, even if, maybe it takes a bit of time to set up. One thing to note here is that if you know the slope of a line, you only need a single point to draw it. So for this example, I'm going to draw the line going through the point 1, 2 with slope negative 2. So let me graph the point 1, 2. And if the slope is negative 2, then to figure out vertical and horizontal changes, we just have to make it a fraction that reduces to negative 2. Super easy way to do this. Just make it over 1. So this means for every 1 unit to the right I move, I go down 2 units. Right 1 unit and down 2. That's my next point. And voila, I have my line. Okay, letter B, I'm going to first graph the point 1 comma negative 3. The slope of the orange line here is given as 1 over 2. So this directly tells you, so when your slope is a fraction, it directly tells you vertical and horizontal changes. So for the orange line, if I move 2 units to the right, then I'm going to be moving 1 unit up. And there we have our 2 lines. So it's not too bad if you know the slope to graph the line. So not only can we use a point and the slope to figure out how to graph the line relatively easily, we can also figure out the equation. We have this very classic looking equation for a line, and it's y equals mx plus b. M is the slope, and b is the y-intercept of the line. So if I just had the equation and I wanted to very quickly draw the line, This minus 1 without the x tells me that the y-intercept is negative 1. And I know exactly how to graph that. I just, on the y-axis from the origin, go down 1 unit. And then the slope here tells me that if I go 2 units to the right, I have to go up 3 units. And there we have a quickly drawn line from the slope-intercept form. So that's roughly everything as far as slope and drawing lines are concerned. A couple other important things that I want to point out. If you have two lines that have the same slope, they are considered to be parallel. And if you have two lines with reciprocal slope that are opposite, you have two lines with opposite reciprocal slope, they are perpendicular, which means they intersect at a 90-degree angle. Let's look at these three equations. All right, so notice that we have two of these equations having the exact same slope. So according to this top statement, they're going to be parallel. And that makes sense, right? That they are going up and to the right in the exact same ratio. For every 3 steps to the right you take, you have to take 2 steps upwards. It's just where they intersect the y-axis is different. This one point here is the y-intercept of the first line, y equals 2/3 x minus 4. And here is the y-intercept of the other line. So let's graph that first line. We go 3 steps to the right, 2 steps upward, and there we have our first line. As I said before, being parallel, they're going to be going up and to the right in the exact same ratio. So having the exact same slope, the only thing that's different about the two lines is their y-intercept. So all I have to do is move this line to the appropriate y-intercept. And there I have my second line. Now this last line has a slope of -3/2, which is the opposite reciprocal of 2/3. So this line should be perpendicular to the other two. Let's draw it. So our y-intercept is 6, then being negative, for every 2 steps to the right I do, I have to take 3 steps downward. And the red line intersects the two blue lines at a right angle. It is a little bit harder to tell that they're intersecting at a right angle because they're kind of slanted. So let me just rotate the entire world here. There we go. And that about wraps it up for this video and for section 3.2.